Last night at 11:53 p.m., a woman was pushed from the roof of a building and her body wasn't at the bottom. We've identified the woman as kinetic energy, a 60-kilogram woman. At the bottom of the building there was a pool, but we don't know if she landed in the pool or on the concrete. Who pushed her? It was her sister, Constance Velocity. They were fighting and she pushed Kim at a rate of 5 meters per second.
Why don't we have the security footage of her landing in the pool?
The street lamps around the incident all went out at the same time because they were on a series circuit. So when the electrician down the street replaced the light bulb, the whole chain of lights went out.
Like so.
Newton's telescopes. This is going to be more complicated than I thought. Assuming that the force of air resistance is negligible, we know that the only force acting on her is the force of Earth.
Let's solve this problem with math.
You're absolutely correct, Ancient Newton. We should use the equation force equals mass times acceleration.
Newton's laws of motion apply to this situation.
That's exactly right. Newton's first law states that an object in motion remains in motion, while an object in rest remains at rest, except for in the presence of a net force. This applies to Kim when she was standing on the building, but when she was falling, the Earth created a net force on her.
However, Newton's second law states that in the presence of a net force, an object will accelerate. This does apply because the net force of Earth is causing the object to accelerate.
What about his gravitational potential energy? What would that be?
His gravitational potential energy, or his GPE, is the amount of energy he would have had at the top of the building. His GPE is equal to his mass times the acceleration due to gravity times the height. What does this tell us?
Since we know energy cannot be created or destroyed, we know that the GPE and the kinetic energy right before impact will be equal. Kinetic energy is the energy of motion that an object in motion has.
So 14 meters per second would be his final velocity, because it was taken right before he landed. We can use this to tell us how long he would be in the air, and from that we can find how far away from the building he landed, and we can find if he landed in the pool or not. From this we know that kinetic energy landed 7.15 meters away from the building, and the pool was 5 meters away from the building. So we know kinetic energy must have landed in the pool and walked away alive.
If she had hit the cement would have acted on her just like she acted on it. Because, as Newton's third law states, for every force, there is an equal and opposite reacting force.
Now that we've solved it mathematically, we can make some graphs. Hello? You're joking, right? You wouldn't believe what's just happened. Constant's velocity has just been pushed off a building by kinetic energy.
My God, she's broken the laws of physics.